A state of emergency has been declared in Santorini, Greece, which is not going to expire until March 3rd, and in the last few days we detected actual evidence of magma movement, but it is not what you might think. During the last week, nearly 8,000 earthquakes have struck a narrow region spanning between the populated islands of Santorini and Amorgos in Greece, equating to a tremor about once every 76 seconds. As a result, more than 70% of Santorini's residents have left the island, some minor damage and landslides have been reported, and schools were closed across at least 14 regional islands. Yet, during the last 48 hours, there was a pretty major development. While the intense earthquake swarm which has been ongoing since January 24 truly is only tectonic in origin, a change was seemingly just detected at the Santorini volcano, although I am still waiting confirmation regarding this piece of data. It now appears that a batch of magma is actually intruding upwards beneath the Santorini volcano, causing the ground to rise at a fairly constant rate, which, if it holds, is rising at a rate of approximately 6 centimeters or 2.4 inches a year. With a presumed volume of magma on the move, recent eruptions, does this mean that the swarm is actually volcanic, or that Santorini will soon produce its first explosive eruption since 1950? To both of these questions my answer is no, and no, as context is key. It is true that ground deformation was only detected at a portion of the Santorini volcano uplift center centered at these approximate coordinates during the last 48 hours. However, the key word is detected. Remember how in a previous video only 4 days ago I mentioned that I checked for signs of ground deformation and found none? Well, I was looking for signs of rapid ground deformation on the initial incorrect assumption that the swarm was overall magmatic in origin, looking only through short-term datasets. These datasets can have a lot of noise, especially if large bodies of water are nearby, so when I did not see decimeters of uplift in a multi-week timespan, I assumed that there was none. However, in hindsight, now looking at longer-term datasets that span all the way back to the beginning of June 2024, I can detect a very weak long-term uplift of 6 centimeters a year. While this is not confirmed yet, an existing model has been recently provided by this scientific paper, and based on the earthquakes since June of last year confined to within Santorini's caldera, it seems to fit the current intrusion as well. Santorini has 2 primary magma chambers, one at 15 to 9 kilometers depth, which is larger in volume, and a shallower, smaller one which is at 6.5 magma intrusion to 4 kilometers depth. What transfers magma from the deeper to the shallower magma chamber are a series of dikes which periodically form, and what do you know, since June of last year earthquakes indicating that another such dike was active were detected at 10 to 4.5 kilometers depth. Earthquakes within the caldera do not get any shallower, suggesting that magma is merely pooling slowly in the shallower magma chamber and is not, I repeat, not actively intruding upwards into the shallow crust with a high risk of an eruption. So, how much magma is involved in this current intrusion? While the 1994 to 1999 intrusion involved only 7.8 million cubic meters of magma, the 2011 intrusion involved 21 million cubic meters of magma, and the still ongoing intrusion of magma at the present seems to so far only involve only 6 million cubic meters of magma. Eruption chanced. If we take these figures and transfer them to a secondary model from the same scientific paper, we can see that such a small volume of molten rock is not expected to produce an eruption. However, on that same end, here are modeled volumes of magma that would be required to result in a magma dike forming from the top of the shallow magma chamber, which might then rise to the surface and erupt. So, is it possible that this slow ongoing intrusion triggered the incredibly strong tectonic earthquake swarm to the northeast? While definitely possible that there's a link between the two, it seems weird that something this intense didn't occur during 2011 to 2012 despite the magma intrusion during that time actually being stronger. As for the ongoing earthquake swarm, if you want more proof that it is truly tectonic, I want to note that as the swarm moves further northeast, the earthquakes occur in multiple trends indicating fault lines which get deeper over time. If these were truly magmatic earthquakes, they would either largely stay the same depth or get shallower over time. Also, during the last 2 days the number of earthquakes and average magnitude of earthquakes has decreased, suggesting a possibility that we may have already surpassed the most intense phase of the earthquake swarm unless a random larger magnitude earthquake happens. Stay tuned for more updates. English